Welcome all to Agentic AI for Enterprise Knowledge Graph Management, presented by Dataraj Rao and Sadashiv Borkar. We'll hand it off to them. Thank you so much.
Thanks, Sarah. Hi, everyone. Thank you so much for attending our session. My name is Dattaraj. I'm the Chief Data Scientist at Persistent. Uh, been with Persistent for the last 6 years, before that 20 years in GE in different roles. We are a global leader in digital engineering and enterprise transformation. And in my role, I lead AI research, looking at the state of the art in agentic AI, Gen AI, and how we can build solutions integrating with technologies like graph databases and large language models. Sadashiv?
Hey, hi, thanks, Satraj. Hi, everyone. This is Sadashiv Borkar. I am a senior data scientist working with Persistent AI Innovation Research Lab. I work primarily on knowledge graphs and agentic AI, help customers to create various solutions across various domains. Very happy to be here and contribute to the Notes 2025. Thank you.
Yeah, thanks, Sadashiv. If you can share the screen.
Yeah.
So what we will talk about today, we have a quick overview of a solution that we have been building for some customers and a quick demonstration of this solution. So we are looking at applying agentic AI for enterprise knowledge management. Besides Sadashiv and myself, uh, we have Prem and Riddhi from our Persistent team who have significantly contributed to this solution and have been building the demo. So thanks, Prem, Riddhi. Let's start with the first slide. So the problem that we are trying to solve is basically, as we all know, enterprise data is highly siloed, it is ambiguous, and often incomplete. So while companies are racing, spending billions of dollars building agentic infrastructures, what we are seeing is the first step is to actually get the data in a state where the agents can understand the data. And that's the problem we are trying to attack with our approach. We see there are silos in the data, there is consistency and low quality in the data. So the agents can't really discover data. Many times things like if you look at a field like customer, a finance system may look at customer as just paying clients, while if you look at something like a CRMS, it may be looking at all, including prospective clients as customers. So there is ambiguity in such terms. There is a core business domain logic that needs to be understood when we look at agents understanding business data. And that's what we try to attack in this solution. Often, because of this problem, discovering data becomes difficult. The ETL process is very varied, and the data keeps changing. So you have new fields, change in the drift of the data, and hence it becomes very important to have a language to understand the data. And moreover, there are compliance risks. Like many times, certain data sets need to be defined as personally identifiable information. So we need to really treat them in a different manner, respecting the privacy of the data subjects. So all this together kind of makes data preparation for agents a very important problem. And we will show one approach that we have taken for this. And our approach focuses on using the graph database as a single source of truth. So Neo4j helps us put this data together, define an ontology, and then have our agents talk on top of it. In Sudhir's keynote, you heard about Aura agents, where agents can now be built directly on the graph database. We actually have implemented as part of the solution, and where we are building agents directly with the graph database, enabling GraphReg and querying data. So we start with an ontology, start with the business. So and for Persistent, we have customers in banking, financial services domain, as well as healthcare domain. So a domain becomes very important to define what the data is. And we look at domain-specific ontologies. So in this example, we have taken a financial services banking example where we have a domain ontology, which is FIBO, which is Financial Industry Bank Business Ontology, that defines the term for the different banking related entities, like what is a loan, what are the documents associated with the loan, etc. So we use this ontology to define a knowledge graph. And this knowledge graph then becomes the single source of truth for the business data. Then we apply agentic intelligence on top of it. So agents now are driven by the ontology. So ontology almost forms like the guardrails on which the agent run. So agent is not kind of hallucinating or building things on their own, but they know what the relationships are between data, what the data definitions are. And using that, the agents start serving their particular purpose for focusing, solving their particular tasks. And what this gives us is compliance by design. So now, because the relationships are maintained, it is not like the agent is using its own thinking or internal memory to make some assumptions on data. It knows that certain data points are related to other data fields. What are the rules? What are the relations? And that really helps us organize the data and help the agents have an ontology-based decision making. And influence the reasoning based on the ontology. And then because the ontology is tied to the business logic, we actually have a very domain-specific agents that come out of this process. Let us look at the building blocks of this system before we get into the demo. So first is the ontology. In our case, we have used financial industry business ontology, FIBO, which is a very popular ontology, though it is very high level. And what we saw was we would have to customize it for specific domains. So in our case, the lending and loans domain, we would kind of customize it. And when we take this to a customer, we often have to make it very specific to their particular processes. But it's pretty extensible. We can extend it to the domain. Second is document intelligence. So then this is an area that is evolved heavily. We have documents in different formats that can be uploaded by the end users. Sometimes they are like handwritten documents which even need to be scanned. So today with the visual language models, we are getting really good at understanding documents. Agents can really understand documents, and especially using more reasoning concepts like reflection, error correction. They can really get a really high accuracy of understanding entities in documents. So combining ontology with a document agent can really help us understand the specific business concepts defined in this document, and that is something we are doing with this document intelligent agent. Neo4j is our core heart of our system. That is the graph database. So once we do all the extraction, we store everything in Neo4j. And using Aura agents, we kind of use the agents to serve this data as well as do a graph rec to collect data from multiple sources and combine it together. And then the connection between these different sources, we have Model Context Protocol, MCP, to call tools with which we do for calling the Aura DB also. And then many agents talk to each other. So we have agent-to-agent protocol where these agents talk to each other. And AGUI is the new protocol where all the agents can have a common configuration and observability UI with which we have built using AGI. So let me quickly talk about the system architecture before we get into the demonstration. So if you look at the overall system architecture, there are the left-hand side is more focused on data ingestion. So we have agents for policy to understand the policy, which is basically written in pure text. It doesn't need to be any fancy format. Whatever is the current policy documents, we take it from the customer, ingest this policy, and convert them into ontology-based rules. Business data and then data from documents are extracted. For documents, we have a document intelligence agents using the visual language models that can extract entities. All this data together is combined with a data ingestion agent which puts it into Neo4j. And all this is guided by the ontology. So if you look at our Neo4j database, that is very much a reflection of the FIBO ontology. And then on the right-hand side, the consumption layer, we use MCP for some agents running outside the system to do validation, to do any. So there may be a standards-based validation specific to the banking domain, which we do. That can be offloaded to a validation agent. That could be a domain-specific data aggregation agents. And these agents talk using A2A protocol. And then for GraphReg, we have a agent. So we use the newest feature, Aura agents. We have used that to actually build an agent within Neo4j to extract information, relate it together, run the Cypher queries, those tools, and present the data to the agents outside the system. And again, because of the ontology, these agents talk the same language. And once the data is available outside, that can be used by very business specific services. So in this example, we'll use a loan underwriting agent, which will look at different documents and try to give an assessment. What is the risk of approving this particular loan from that individual? And we will show that process by connect by our AGI powered UI and connecting to a system where these different documents get uploaded. So that's in a nutshell how the system will work like. The heart of the system is the ontology driven by the business and the Neo4j database, which becomes like the current state of the system. And the agents work off this state, talk to each other using A2A, and accomplish very specific tasks. So I'll hand it over to Sadashiv, where he will actually show you the details of the system. And it's almost like taking an example of a domain person. He will walk you through how the system would look like. So Sadashiv, over to you.
Yeah, thank you, Dattaraj. I hope I'm audible. So this particular demo is about in this particular demo we are addressing the problem of inconsistent and fragmented financial data. Auto loan and underwriting for an auto loan solution for specifically for a underwriter persona. For this, as Dattaraj explained, we are using FIBO. Okay, and the goal is to kind of create a knowledge management solution for identifying the key concepts like loan application and risk assessment, underwriting, and so on. Okay? So I will quickly open the demo. So this is the underwriting application where I have to submit all the documents required for applying for a loan. So this is where I have submitted whatever is needed to apply for a car loan in this case, right? And the next part of this is as Datta also has touched based on that how this happens, right? I'll quickly cover that. So we have used the FIBO ontology to drive the ingestion of the data from these documents into the knowledge graph, into the Neo4j knowledge graph. So we have customer documents being submitted. We have doc intel agent, which kind of extract the entities in the key value pair. This is the first agent which is being used to access the document. It can classify the document as to what kind of document has been sent, what kind of entities has to be extracted from those kind of documents are defined in the template. So very powerful, very intelligent agent, this doc intel agent, which extracts the entities from those documents using key value pair. Then there is the next agent, which is a data ingestion agent, and here is where we are using the FIBO ontology at runtime when we are loading the data from the loan application itself, right? So the way we have designed this is that the entities are the FIBO ontology has become a part of a JSON file, and when you read the key value pair, the agent decides that what merge statement it has to create to kind of generate a cipher query with the merge statement to identify what kind of data I should enter into a knowledge graph. And that's a merge statement which has been executed by the agent, and it puts the data into Neo4j. For doing this, we are using the Neo4j MCP tool, MCP servers, and there are tools which we have kind of designed for this particular specific task. So this is the first part, that you are using ontology and agents to ingest the data which is coming from the particular loan application. So this is the ingestion part. The second part, what happens after the ingestion is that there is a validation which happens. Now in this particular domain example, you have something called as a bank policy document, which is like a document which tells about what kind of credit ratio you have, what kind of vehicle age you should accept the loan for, and so on. So there are a lot of rules which are being defined for that particular business. In this case, the car loan application, or vehicle loan application. So in this particular agent, the way we have designed is this agent connects to this Neo4j MCP server. It's a workflow where we have 5 different checks happening on that particular loan application. In this case, the credit score checker, the DTI, the LTV, and so on. So these are 5 different tools which we have created. The tools are intelligent enough to understand, to read the loan application, to read that particular part which has been coming from the loan application and the supporting documents, and kind of calculating whether, and comparing that with the bank policy document. Okay, and that's where it checks whether any of the documents or any of the data which is being submitted by the customer is violating that. If it is violating, it will kind of create a relationship between that particular applicant and the bank policy document. And then that it creates a relationship between them. They're saying that, hey, this particular application is violating that particular rule or that particular check of the bank policy document. So this is under agent which runs with the and helps the underwriter to kind of quickly assess at a high level what whether the loan application is valid or not, and what kind of violations it is being doing. It also has the capability to classify the violations, whether it is like a severe, a medium, or completely pretty worse kind of violations. So that's a second set of agents which we have. So now, after these two steps, what we have in a Neo4j knowledge graph is that application about and it has all the information what has been submitted by the customer, plus the validation checks also has been done. Okay, so now going back to this is how the Neo4j, this is how a schema looks like. So we have this schema, and we have loaded dummy data with few applications, and this is like the complete knowledge graph for the 7 different applications which we have kind of loaded with various stuff. Let us look at one particular. If I query one particular application 7, this is how it looks like, right? So this is my application. This is the loan, the bank loan the bank loan policy. These are the different. I will just try to blow it a little bit. Yeah, these are the different checks or the rules which are associated with this particular bank loan policy. This will be common for all the applications which are coming, right? And this is the applicant. These are the different parameters for this applicant, and this is the application. And then if you see here, it has kind of identified it violates violates this. So for this particular application, as you see, there are 5 checks which are being done, and 4 of them are kind of violated. So you see that case here, right? So this is how the data is now ready in the Neo4j for underwriter to be consumed. Right? With that, I will go to the application which we have developed. So this is the application which underwriter sees. It has these applications coming up, and then let us look at this particular application, which is APP07. And if you see, the underwriter gets a quick first view of what the application is as a graph. And if you see, the 4 violations which are coming in here are depicted here as well. So we have the borrower, we have the debt obligations, we have credit scores, and as we had said, this schema is again based on the FIBO. So you will see all the nodes and the relationships which have been defined here are complying to that of a FIBO. Okay, and these which are being read are kind of violated. So if you look at here, this policy clause which talks about the maximum age of the vehicle should be 7, that has been violated, and it similarly for this there is a another policy clause which talks about the loan to value ratio, that has been violated. So there are multiple violations for this particular application, right? So this is how we look at. I will quickly show you one. So this is what the Taraj also touched based on. This is the execution logs of the validation agent which we had executed. Okay, and if you look at this is how the AGUI protocol shows you how the agent has worked. So basically, AGUI is like a lightweight protocol that standardizes the communication between the agent and the UI. Okay, so you can have currently AGUI supports LangGraph, Crew UI, Agno, and so on. So it kind of whatever agents you have, the way you are going to see the stream data coming from the agent, right, is will be consistent. So that's a power of this AGUI protocol. It kind of it shows you this JSON. It creates a JSON file and shows you the streaming structure over SSE on the UI. So this is the AGUI implementation for the validation agent. Now we have other agents here. So there is a policy agent, and now this is the underwriter person who is looking at this, right? He can browse over all this information, and then he can invoke certain agents which we have created, which are very domain specific. So there are some agents which are policy agent, which are credit agent, and violation agent, and collateral agent, and this is like a recommendation agent. So some of these agents are used in LangGraph, because for LangGraph, because for these agents we need external data coming in as well. For example, for credit agent, whatever has been identified by the documents which are submitted by the customer, we also need an external agency data or some third-party web search data to kind of assess the credit as credit risk for that particular borrower. So that's why we have it in LangGraph. But we also have kind of created violation agent and collateral agent, which are very specific on KG, and that's where we have created the Neo4j Aura agents. So these are Neo4j Aura agents. We have kind of created the API out of the Neo4j Aura agents and have integrated in our packet. So when I run, let us say I run a collateral agent for this particular customer, it will give it runs on the KG, and this agent doesn't need anything external to that of the KG, and that's why we were able to create it in the Neo4j Aura agent, and it executes and gives you the description, gives you the recommendation of the way it has run. It gives you what is the collateral information, what is the information in this case about the car or the vehicle, which has been in question. So it kind of gives you that detail of how the Neo4j Aura agent has kind of worked down here. Similarly, you can also run in the same pane. You can also integrate the credit agent as well, which is as I said, which is LangGraph agent. It kind of gives you the credit information. So this is again using the KG data plus external data and try to assess the credit risk for that particular applicant. So in the solution, yes,
I'll just interrupt a little bit. There were some questions on when to use what agent. So at least our view is Aura agents typically when everything is in GraphDB, in your GraphDB, Aura agents really work well, and we are exploring them actively, and they are pretty good. While if there's some external connections, we went to LangGraph because there were some connectivity issues and all. But ideally, we would want to have something in Aura agents which can do the database access. Yeah, go ahead, Sir.
Yeah. So these are typically agents which we have created, and then we have like this is for that particular application. The underwriter can assess this application by running all these agents and get assess in a complete fashion. This is another language. So this is a recommendation agent which depends on all these agents. So when you run these agents, it's a workflow which kind of runs and kind of gives you like a complete recommendation by running these 4 agents in parallel. Then we have gone a little bit ahead and seen what happens when we have agents from LangGraph plus we have agents coming from Neo4j Aura plus we have Neo4j Aura agents as well, and how to integrate them. So we have created a layer. So this is the way we are envisioning is the underwriter would go and let us say he wants to assess for that week or for multiple days what is the scenario where we want to like how many loan applications are violated and have violations, and what is the credit assessment for that particular violations. Now what's happening is here, what we are doing here is we have this violation agent in the Neo4j as a Neo4j Aura agent and credit assessment agent as a LangGraph agent, how they communicate with each other, right? So that's where we have created this happens on the A2A layer, and that's where we have created a custom orchestration for communication with the Neo4j Aura agent, which would follow the A2A, and these agents will interact with the LangGraph to kind of give you a certain information which you are looking for. So if I run this, right, so what I have done is I have selected a date range and I have asked a question. The prompts kind of take this data, and if you see here, it assesses It kind of assesses, like it said, okay, this is a violation agent. It has kind of identified these two applications which have been violated, which are applied on this date range, and then these are the applications with which has recorded a violation, and then this data, the data from the new 4G Aura agents are being passed to the line graph to do the thorough credit assessment. So for this application, which is for borrower 006, you get the credit assessment, and then for the application 007 as well, you get the credit assessment. So we have created this custom custom wrapper, which can help the new 4J Aura agents interact with any other agent. In this case, it was a line graph. So this is what the A2A layer is. Yeah, one more thing that we are connecting to the MCP server, and I showed you this, right? This is how we are connecting to the MCP server to the violations and so on. Just go back and yeah. So okay, I will quickly show you the. Yeah, so these are the agents which we have created. Yeah, so the collateral agent, the violation agents these are the agents which I just described and just showed you. Let's say this is a collateral assessment agent. So we are working on this. We can ask the same questions here to respond. The way we have played around these agents, and we have found that you need to give a good description. You need to give a nice prompt instructions how this would work. It has a very great feature that just click this as external and say save, and it will kind of make that API tool available for you. That's a very super like just like a one-click deployment of your API. And then here there is one second, I don't know. Yeah, here there are different tools which you can use to create these new 4J Aura agents, like Cipher template, text to Cipher, similarity search. We have played around with these two for this particular case where I'm getting the collateral information from the KG. This is the sorry. So this is the. I'm not able to click the screen here. One second.
Yeah, we must say that I mean this system is very intuitive. I mean kudos to the Neo4j team, because we have been playing with many agent systems, but these agents like just started working in the first shot out of the box. Yeah, go ahead, Sarshu.
Absolutely, yeah. So this is the tool, right? This is like for the we are using the text to Cipher tool. We have kind of given a description. We have even if we just mention this, it works. This kind of information about the if you know the schema very well, it kind of works much better and much faster to say that okay, focus on these things and so on. So this is like a tool which internally works. And when I can quickly run this and show one second. So the way it runs here, we have kind of captured the same thing. I think I missed to kind of show you that. I will just go back here. Yeah. So if you look at these descriptions, what we are getting, and the way we have executed this. After we execute this particular, you will see the way the Aura agents. Yeah, so this is executed, right? So you see the way the Neo4j Aura agent executed. It kind of gives you not only gives you the answer, a very detailed answer. It kind of tells you the reasoning as well for that particular agent, right? So it has said what kind of query it has used, how it has created the Cipher queries, and so on. And so the similar thing, what we have also tried to replicate. So this is the case I was showing. This is A2A example. I missed to show this. That is communication between the Neo4j Aura agent and LangGraph, and we are capturing the steps here as well in the similar way. So there is a violation detection agent which is from the Neo4j, and we are able to stream whatever is Neo4j doing directly on this particular UI and show that here. And these are all the details. And these are the credit agents. So there are two credit. This is the LangGraph agent which is being running, and we are showing some recommendation on what is happening for the LangGraph as well here. But what you see here for the Neo4j Aura agent is exactly what you will get here. as a thing. So it is pretty powerful, very apt example of using agents with Neo4j knowledge graphs.
Yeah, I think it's we're almost wrapping up, but thanks everyone for attending. I think we really enjoyed connecting the business ontology to agents to Neo4j, and kudos to the team. I think the Aura agents is amazing. Lots to look forward to. So thank you everyone for this session. Have a good day. Bye.
Thank you. Bye.